So here we have a particle that's attached to one end of a light inextensible string of length of 1.6 meters. It says the other end of the string is attached to a fixed point. The particle moves at a constant speed in a horizontal circle with the string inclined at 55 degrees to the vertical. All right, so once it's calculated L1, the tangential speed to the orbital period. All right, so the system is here. Here's some mass unknown. Here's the length of the string. L here is given as 1.6 meters. The angle, it says touching the vertical, which implies that it's this top angle. That's 55 degrees. R being the radius of the orbit or this conical system here. And then V here is your tangential speed. All right, let's go ahead and do it. I'm going to go ahead and remind you that for a conical system, we keep our x and y coordinate the same. Sometimes in physics we tilt the axis so that it, fits the line of motion. Here, the line of motion is just in a horizontal plane, so we don't need to do anything. I'm going to draw my forces out. Here's F of G pointing down, and then here's tension in the string that's pointing along the string towards the fixed point. And then keep in mind that y and x are normal. Therefore, this T here, the tension in the string, is in the northeast direction, so it has to have components. Here I want to draw tx to the right, and then I want to draw ty pointing up because it is to the right and up. And then while the diagram and the statement tells you that the angle given touches the vertical, which is 55 degrees, I personally like to use the angle that touches the horizontal axis. So in this case, I want to take 90 degrees and subtract it from 55, and that's going to give me this 35 degrees. You don't have to. I personally like to, only because then I know x is cosine and I know y is sine. Okay, so that's entirely up to you as you practice which angle you like to do. You always find this angle because it's just easier. All right. So therefore, I want to set up my x and y information because these types of system is for the most part designed so that you have to substitute. Here, I'm just going to say f of c is equal to tx. Well, the only thing that's pointing towards the center of this particular conical system is tx, which is your centripetal force. So I'm going to say centripetal force is equal to tx. Well, I can break centripetal force down to mv squared over r. Please keep in mind part A wants us to find the tangential speed, so I'm going to introduce that right away. And then tx is t cosine of 35. Okay, once again, because I like to use this angle that touches the horizontal axis, x is cosine, and then y is sine. So here tx is just t cosine of 35. Make sure you don't put 55 here, okay? So I've decided to use 35. All right. To get v squared by itself, multiply both sides by r. So the r that's in the denominator on the left side is now to the top right. And then you have to divide m to both sides as well. So m gets moved to the bottom right. So this is what it looks like. Okay. So here, I don't know what t is. I don't know what m is. But what I do know is I can find r. The length of the string is given as 1.6. So you have a right triangle, right? Watch my cursor. You have a right triangle. That's L. You go down. That's your y leg. And then this is your left leg. So you have a right triangle. So I'm just going to say cosine of 35 degrees. Well, cosine is adjacent. My cursor from starting from M all the way to the post, that is a length of R, because in the diagram that says little r. So that's R, which is my adjacent. So cosine of 35 is adjacent, which is R, over hypotenuse, which is L, and that's that. Well, to get R by itself, I can just multiply both sides by L, but L being 1.6 because it says so in the wording. Okay, so that's where the 1.6 come from. So multiply both sides by L, and I just substitute LL for 1.6 meters because that's what it says so. And then if you punch it in the calculator, you get 1.6 times cosine 35, you get 1.31 meters. So the length of the, the radius of this conical system, horizontal plane is 1.31. So the little r in this diagram is 1.31. Well, I just found, out of 3 missing variables, I found one of them. I know what r is, right? It wasn't given to me, but using the information, I figured out what r is. I'm still left with T, and I'm still left with mass, though. I don't know what the mass is, and I don't know what the tension in the string is. But that's okay. Now, we can just go ahead and set up the y information, right? So here, we have Ty is equal to f of g. Ty is pointing up, f of g is pointing down, and these are the only two force components that are in the vertical direction. The bob here, or the mass, is tracing out a horizontal plane relative to the floor, which implies that the bob is not moving up or down, so it's moving just in a perfectly horizontal plane, hence a conical system. So therefore we know AY is 0, because AY is 0, you need a minimum of 2 forces. Here we have TY pointing up and F of G pointing down, so I know they have to equal in magnitude. Okay, so I'm just going to say TY is equal to F of G. Well, I can break ty up into t sine of 35 degrees, and then f of g I can break up into mg, and then as you can solve for t here, I do want to point out there's different ways to do this. Okay, you have two unknowns, right? You have t and m. Once you get to the statement that I'm circling here, you have t and you have m, because you already know what g is. G is 9.8. So at this point, it's up to you if you want to solve for t or solve for m. I'm just going to solve for t. Okay, so there's different ways to do this. I want to solve for t. So to solve for t, I divide both sides by 35 sine of 35 degrees, which is right here. Now that I know what t is, I can just plug in 9.8 for g, and then keep in mind that the negative sign is already taken care of for you because ty is pointing up. Okay, so in this case, using a positive 9.8 makes sense, not a negative, because otherwise you say t is negative, and then but that can't be. Sine of 35. So here, I do want to point out, in case you're sloppy, the mass is known as a little m here. Okay, so this little m in the front, this is mass, not meters. In the parentheses, this is 9.8 meters per second squared. So this little m as well is representing meters, while the m on the outside represents mass. So as you practice, please know what m represent, right? Don't think this is meter just because it's small m. This is mass, because up here it says mass times gravity. So I carry the mass down. I substituted g for 9.8. And then if you take 9.8 divided by sine of 35, you just get a number, which is 17.1 meters per second squared. And then the m to the right here, this is your mass that I carry down. Okay, I could have kept it in the front, but I just moved it to the right because I like my coefficient in the front. All right, other than that, now you know what t is. T is 17.1 m for mass. So therefore, I can substitute out t. T is 17.1 times mass, okay, times cosine of 35, and then times 1.31, and then oh, I think I'm missing a parentheses here. Forgive me. But it doesn't matter. Here, mass is going to cancel out. Mass on top, mass on the bottom is going to cancel out. And therefore, you can simplify all this on your calculator. So if you take 17.1 times cosine 35 times 1.31, you'll get 18.35. But to get v by itself, we square root it. So therefore, we square root 18.35, and that will give us an answer of about 4.28 meters per second. Here, I'm not including direction because it says tangential speed. Keep in mind that as an object is being swung in a conical system, its direction constantly changes. Because its direction constantly changes, we say that the object accelerates because velocity is speed plus direction. While the speed stays constant at 4.28, the direction always changes as it's moving around in a circle. Okay, so speed is constant, velocity is not, because velocity has direction, and direction changes all the time. All right, other than that, let's go ahead and crack out part B. Part B is pretty straightforward. It says what's the period, t. So notice t here is for period, not tension. Okay, and this is where sometimes folks get confused. You know, m for mass, m for meters, t for tension, t for period. So know what it is that you're asked to find here. It says the period, which is commonly denoted as capital T in mathematics. Here, to find the period, I'm just going to use v is equal to distance divided by time, or speed is equal to distance divided by time. Well, I know that distance in this case is the circumference of a circle, because here the bob traces out a circular plane relative to the floor, or parallel to the floor, right? So circumference in math is 2 pi r, and then here's time. Well, t here is just capital T. So if I'm wanting to use circumference of a circle, the time that it takes to complete one revolution or one cycle is known as capital T. Therefore, I can just go ahead and move t up to the left side because I'm trying to solve for it, and then I'll move v down to the bottom right. So therefore, we say that t is equal to 2 pi r divided by the tangential speed. Well, we know what r is from our previous work. R we calculated using the length of the string and breaking it into a right triangle. We got 1.31 meters here. So it'll be 2 pi times 1.31. And then v, the tangential speed we found in part A, which is 4.28 meters per second. So if you simplify all this on your calculator, you will get a period of 1.92 seconds. Okay, and that's it. I hope that helps. Stay nerdy, don't be whack.